probably now go into the other entity that has been very, I mean, this is not because I'm part of it, but has been very helpful in promoting the S&T ecosystem in the country. This is the project USAID Stride, and today we have Richard Abendan, who is the chief of party of Stride 2, to describe to you what Stride is doing now in the last couple of years in terms of our efforts towards promoting entrepreneurship and technology commercialization. So, Richard, please take it away.
Thank you, Al. Can you hear me and can you see my screen, just to confirm?
Yes, and yes.
I'll be turning off my video to save on bandwidth. So good morning, everybody, and good evening to everybody in the US. I'm really happy here to talk about the DOST Philippine-Innovation Entrepreneurship Core Program. First, it's really a DOST program. That's why it's in the title. So really, if anything, my co-presenter should be Dr. Eric, also speaking after me. This is really a DOST primarily funded project, working with the Stride program, working with De La Salle University, with RTI International and GW on really creating this program. And it's really just sort of just go to the headlines. What's the FEC program? It's really about helping our researchers do market validation early. And so before I go to the meat of what the FEC program is all about, again, I think it's something to just want to give you the context about why we're doing this and sort of give you a quick plug about the Stride program and the project I represent. Again, we're here to do to strengthen science, technology, innovation, research capacity for inclusive growth in the Philippines. So you can see here that for that to happen, we really need to have commercialization happen from our research in the universities and our research institutes. So we've been around for the last almost 7 years, $38 million just for the Philippines, again, towards inclusive economic growth through STI. And I think many of the partners here today, I see a lot of familiar faces. Also give a quick shout out, you know, Liza Virata, who started me in this journey with Stride, also with PAASE, Dr. Bacungis, Ana Villalobos, Irene Villasenor, our partners in Stride, CP David, Crystal Villanueva, Villaluna, Joy Banaus, one of our grantees, Joyce Ibana, Carlito, I think is a big part of this effort also. Mylene Leggett I see here, and Louis, of course. I think we've collaborated a lot. I think it's good Louis started before me, because that's a lot of initiatives that I think we are also working together. I want to say quickly that this it takes a village to really bring about commercialization, right? So I think all the efforts here are really important. We really have to work together. It's a tough effort to get commercialization going. Obviously, Gani, Al, Giselle, and Joe has been part of the Stride effort early on also. So the FEC program, again, is a collaboration between DOST, DLSU, and Stride. And I think we're going to this question about, you know, how do we make S&T research equate to innovation? And we sort of have a definition for innovation here about translating ideas and inventions into products and services people are willing to pay. That's the important part, right? That's what commercialization is all about. If there's no willing market, then there's really not yet an innovation. And so I think Carlito started this this session, and it's a good example, right? Where you have a chemist who sort of now is an entrepreneur also, and that journey is also not straightforward, right? And it's somewhat personality driven, also experience driven. And so I think that's something that with this FEC program, we sort of want to sort of facilitate that transition. And you will also see later on that you don't really have to transform everybody to become an entrepreneur to sort of commercialize our research. And I think that's, I think, the big power of the FEC program. Sort of to throw a wet blanket in terms of this effort on commercialization, I have a graphic here from the AUTM, Association of University Technology Managers in the US. It's a pretty old graphic, 2016. It talks about all the great outcomes from university-funded university research, right? Billions of research expenditures, new products created, licensings and revenues, and number of patents. But I have another screen grab here on the right. Again, this is relatively old, but I think it still holds true, right? That most universities actually lose money in terms of, if you look at it as a business, in terms of investing in R&D towards commercialization. It says here, you know, only about the top 5% earners are only, you know, 8 universities. And the top 5% earners took 50% of all licensing income revenue. And the top 10% took 70%. So you can see that most universities, in terms of numbers, actually don't make a lot of money in commercialization. Also, again, only 37 universities have been able to reach the top 20 in licensing revenue in a given year. So just to show you the sort of difficulty in looking at commercialization, it's not obviously a straightforward journey. locally in the Philippines, there's a picture of an M&E conference by DOST that we've helped out in terms of the technical components. Is that, you know, DOST is also looking at how do we look at the economic impacts of our investments in R&D. As you can see here, I have a red arrow here on the right, on the left here on this row on economic impacts. And so these are the new M&E frameworks for R&D projects in the Philippines. So you can see things like outputs, like patents, they're all there, the usuals. But now we have outcomes like profitability, cluster growth, net investments. So these are the new metrics for investments. And I think going forward, our commercialization efforts across everybody here from DOST, PAASE, UP, really will help sort of meet these sort of performance targets. I want to quickly just sort of show that, again, it takes a village here. We've done efforts on technology transfer, capability building in the Philippines with universities. We've gone to the US. We partnered with DOST Shared also and Upscale with Louis here on the KTTO Impact Program. Again, building technology transfer capabilities in Philippine universities. So that's one part of it, right? And all these are the functions of a KTTO. We're building capabilities in the university here, bringing in services. But now I want to talk about how we want to sort of transform our actual researchers, right? Because that's part of the equation, not just the services, not the tech transfer office, but the researchers also have to push this. And again, we also work with many RDIs and TBIs. Again, it's a big ecosystem. Obviously, TBIs play a big role also. So now let me go back to this market validation question and what the Philippine Innovation Entrepreneurship Core Program is all about. And you know, it's primarily based on the NSF I-Core, since the name is pretty close. And many of our researchers in the US might be familiar with this. And it sort of asked that question, NSF initially. You know, we've been investing about $7.5 billion in US taxpayer dollars in basic research. But how do you start showing outcomes, right? And this is something I think even our Philippine government is also beginning to ask. And so taxpayers should be benefiting from commercialization. But still there's that sort of impression that researchers weren't developing technologies that meet customer needs. Obviously, basic research also does not have a direct commercialization bent. We know that. So, but to be fair, there's sort of that impression. And so NSF worked with a Stanford Lean Launchpad curriculum to sort of look at how can we do rapid customer discovery to sort of test and validate these research ideas even before they become a spin-off. And so just, there's an old statistics. I know it's grown a lot, but since 2010 to 2016, about 905 teams have gone through this in the US with about $105 million raised. So that's the I-Core program in the US. And just to show you this, pretty much the main design of this. You form a team around the technical lead, which is your principal investigator. You can imagine your academic researcher or your research institute technical lead. And you actually build a team around that. You build a mentor, you put an entrepreneurial lead to do all the business development projects. It doesn't have to be a scientist or an engineer. And I think Louis talked about mentors. We've heard about it from Jerome also, right? About talking to customers, also having a good mentor program. I think it's all here, right? It's not a new concept by any means, right? We're trying to put a system to this, but you build a team. That's, I think, a very important part of this I-Core program and the FDC program. We're not letting the researcher, principal investigator on their own. We build a team where they can actually now supplement and have a synergy in terms of all their different capabilities. So you have a team around it. It takes effort to build these teams, by the way, and Al's been a big part of that. It takes him months of bugging mentors to help out a particular project to be part of the team. In the US, it's actually competitive. You apply for a program, you have a team, you must be an NSF-funded researcher, and in our FDC program, it's similar. You must be a DOST-funded researcher, and then you actually get a sort of a financial incentive to be part of the program in addition to the training. So what is the FDC program or the I-Core program in the US? It's really a one-week training first about how you do a lean business model or business plan, and really doing a lot of rapid customer discovery efforts, interviews with markets, and that's what this program is all about. There's a lot of mentorship involved there also with the team going forward. And finally, there's a sort of a capstone class at the end where they discuss their learnings and refine their business model canvas. Again, this is a US example of a team on the right. You see they're counting interviews, and that's actually the performance metrics of this project. I want to highlight at this point a very important part, that we're here to transform the researcher, sure, but you don't have to, right, to become an entrepreneur. There's this team around that. And I think that's very important here, because we don't really have to rely on the resources, the time, the energy of our main investigator. They can focus on the research and the technical side. But if you sort of have a sort of immediate startup effect, creating this team around them, something very important to think about. Again, it's based on several principles. We're creating a business model, not a plan. I like this part about, a startup is a temporary organization to test a value proposition, right? So in a way, it's all right if you fail. I think that's something that we always sort of push into our startup community, that it's not necessarily always you have to be succeeding at the first time. Obviously, it's an iterative process. We want to create a valuable product, and we sort of have a flipped classroom design where actually the students are the one reporting most of the time. It's really about getting out of the classroom. It's really about customer development. So sort of, again, two elements: the business model canvas. Many of you are familiar with this. It's just a rapid business plan. You have this little canvas where you have to answer these different questions. Who are your customers? How will they get it? And how will I grow my customers? All these different components. And it just takes a few days to go through this. And you'll see they actually refine this as they go, the teams. But really the big part is a customer development. And that's really just networking and talking to people. And the way you have to force them to talk to people. Just a quick, we actually got NSF I-Core certified instructors to come here to run these programs. We ran 2 batches of these. And again, these are our instructors, also along with our instructors from RTI International. We're actually building a local capability here of mentors who can actually sort of give this kind of training in the future. Just to give an idea, again, we ran 2 of this already, one in 2018, one in 2019, it's about a 6-7 week program. Again, the kickoff workshop, a class for a few days, all the forced interviews. I like to use the word forced, and really at the end, a capstone course. This is a picture of the batch that was done in DLSU. I think this is the 2nd batch already. And you have Jim Chung on the lower left here working, and that's Bob Story in the lower right during that training program. You see Al in the foreground here because Al's been there. I think that's Louis there also. So you can see, it's all the same champions in commercialization, and really trying to learn from each other here as we go through this program. Again, we've done 2 batches of this, and this is the first batch. You can see it's different technologies. It spans everything from energy, health, medical devices, agri. So you can see the sort of the spread of that. And it really initially involved Picard, PSHERD, PCHRD projects also. Later on, it became more of a PSHERD focus, but you can see even DOST institutes like PhilRice were actually part of this program. So individual teams, again, we built around them these different concepts and products. Just want to show you now quickly sort of some of the teams that we've sort of had in the last 2 batches. This is like the hybrid electric train. And you can see we have some great outcomes from there. One thing I like to show about this, see their slide, they actually showed their number of interviews. There's this big push to again have them have a lot of interviews. But even the NSF folks were really surprised because we have this team here that before going through a program actually had the train already. So they're really impressed. But one thing that we found out was like, hey, the cab length after all these interviews had to be shorter. Right? And so these are big insights you get with talking with customers. Again, a team from Mapua, just to show you the spread of the projects we've had. This from UP Las Bañas with Apticon. You can see again that there's a mix of the investigator. We have a tech transfer officer and also an entrepreneur, or maybe as a mentor. You already need these different components to really create a rich project. There's of a DLSU on the exoskeleton, the project Agapay. I want to also point out that we can get great industry mentors like Earl Kua here, who runs a big semicon firm, because really they can open doors and give great insights to our teams. So just to sort of wrap it up now, what are the outcomes, right? And I have these 3 bullets just to sort of in words to show, hey, we've increased technology readiness level, and Al can talk a lot about that. One team has found an industry partner. The one about the train shifted their development towards what the Philippine National Railway specifically wanted at that period of time. For the FDC 2 cohort, their TRL, some of them have progressed. One went to have a pilot testing in terms of prototyping. The one with the tablet, with one of them on the health, actually partnered with a pharmaceutical company in evaluating their tablets. Again, there's this increase in readiness, in innovation, in investment readiness. Fertigro is a good example. And I sort of want to just show you 2 quick things. Like this, the one with Fertigro, I believe, on their work with the Panama disease. And actually through this FDC program, through their interviews, they were actually able to enable a 5 million grant or funding, I think from SBC, and actually found an industry partner to actually help pilot or sort of do a prototyping, actually open doors for a soft landing in Thailand. The iron fortified rice project actually is also interesting. They actually realized that they had to actually change their market segment. They were originally looking at end users, the actual buyers of rice, and actually the grain producers. But now they're actually realizing that the LGUs were actually the big market for some of these iron fortified rice. So again, I think those are the concrete outcomes. But I think the bigger, more important outcomes, I think, will be how the realizations of our researchers and the teams, right? And we actually asked, what are your aha moments? And besides a partnership, it's about realizing the different markets that they have, how many interviews. Again, we have a statistics here, 234 interviews of 10 teams in 3 weeks, right? And how they are able to pivoted their projects to actually get more funding. And I'll sort of end with this sort of last couple slides with these are just quotes about, and we have a video of all these testimonials from our 20 teams. There's like 15 minutes long. I didn't want to play it, but I sort of took out and paraphrased a few quotes, and you can see it's sort of a mindset change, right? And this doesn't happen overnight. It takes time. And you know this, particularly like Louis knows, he's working with academic teams, but things like, and now I have to look at all markets. I have to go to the field with clients. I have actually met our competitors during this interviews and actually know about their products. There's an interesting comment. I learned to ask open-ended questions, not yes and no questions, but actually something where we can actually learn more from our customers. I've learned increasing our partnerships with LGUs. We expand our thinking, not just looking at the local market. I think this is for the hybrid electric train, actually, where now they were saying we can actually just export some of the components. And again, it's something about learning about understanding the market, right? As scientists, we don't think about it too much, maybe, but really that the market rules at the end of the day. So these are the realizations. I think that's hard to capture with numbers. That's something we could bring out from this FDC program. So learnings, I think finding, it's great, looks great, but there are difficulties to do this. Primarily finding principal investigators who are really interested in doing this, and forming a team around them is not easy. You need a good dynamic between all these members. And many teams have to be encouraged to do more of these interviews because, some people are uncomfortable trying to just do a cold call, right? And so how do I get to these networks? That's what this program is all about. It's really encouragement and mentorship. And sometimes just some good old-fashioned pushing. And really, how do we define the success of this kind of training? And even the other similar trainings that Louis talked about, and maybe around TBIs, tech transfer, the outcomes of these won't happen quickly, right? And so we can look at TRLs, licensing, sure. But how about the teams that sort of realize, hey, my product may not be the best thing right now. I have to go back to the drawing board. I have to make a large pivot. Are they a failure or a success? I think for us, it's also a success, right? Why would we start investing more when we can actually transition and do a better product in the future? So I think this kinds of learning is something we have to sort of build in as we do the metrics on this kinds of work. Finally, why do you want to do this? Again, we want to create more startups, design more research that meets industry needs, make our students and researchers more entrepreneurial. And again, these are common goals across all our programs here, across STRIDE, PAASE, and DOST, and other partners in UP and academics. I want to end with this one last slide. Fine, we're doing all these programs on tech transfer, TBIs, market validation training like the FDC program. But we also have to ask, we're targeting people here, right? But how can we also change our structures in academic institutions and research institutions to meet the challenges of innovation? And so for the STRIDE program, that's why I sort of made a little shout out to all the different people here in this group that's been part of the STRIDE program. FDC is not just, it's a small part of it, but we're also working on innovation readiness with our HEIs, policies on incentives and extension, more efficient research operations, new metrics for R&D, as I mentioned, mechanisms to better engage industry. To your point, Joel, we'll be happy to keep working with everybody on how do we sort of, solve the riddle of industry academe partnerships. But I think we'll still be here for almost another year. So we'll be happy to work with you all and give us ideas on how we go through this program. So that's it. Thank you very much for your time, and we'll be happy to answer any questions and discuss this in the future. Thank you.
Thank you very much, Richard. I almost got kicked out again. So, but clearly, again, this is another one of those that we were talking about FEC at the last PAASE meeting in 2017. Just describing the program to our group, and in 2018 we implemented the first FEC and a second cohort. We were supposed to have a third one this year, but unfortunately with COVID, it was very difficult to recruit teams because we'd have to go meet them individually and encourage them to take on to the program. Hopefully with this presentation, a lot of you guys in the audience will start considering taking part of FEC 3 when it comes online next year. And I hope Eric is in the audience, will support it as well, moving forward beyond the life of Stride.